So let's talk about what you find on the back side of the spec sheet of your machine. You find a serial number here, and that's a reminder to send your warranty card in within 14 days of your receiving the machine. If you bought the machine used, request another warranty registration form and register the warranty under your name, not the previous owner. Then up here you have who made the machine, what model it is. Then you have the country of origin, a maximum input on amperage, effective input on amperage. The way how that works is, this is your maximum draw ever, and this is like an average based on duty cycle, which now leads us into duty cycle. You see a bunch of numbers here, you see a percentage, and you see amperages and voltages, and duty cycle is like the most misunderstood topic in the welding world. Basically, duty cycle is based on a 10-minute cycle. So if you have a 100% duty cycle, that would be 10 out of 10 minutes. 60% duty cycle would be 6 out of 10 minutes. 25% duty cycle would be 25 out of 10 minutes. The way how that works is, duty cycle is measured, if it's done correctly, in a laboratory, and if there is no other numbers mentioned, and if it's done by the proper standards, it's done at 40 degrees Celsius, which is 104 degrees Fahrenheit. Inside this machine, there's like the fan in here, and it flows air through the machine across the heat sinks and all the components that are in there. There's components in these machines that should not exceed 140 or 150 degrees Fahrenheit. Now, if you put 104 degree air inside that machine, those are the results you should be able to duplicate and to measure. So what's happening here, this is for stick welding, TIG welding, MIG welding. For MIG welding here, let's say at 100% duty cycle, there's 120 amps, 20 volts. So that's a setting just shy of 1/8 inch. So you could weld 1/8 inch material with a zip tie around the trigger all day, day and night, forever, at that setting. Now, there's a lot of guys that weld thicker material and they weld longer than what the duty cycle says. For example, if you weld wide open at 200 amps, you only get 2.5 out of 10 minutes that you weld, and then you need 7.5 minutes cool down, and this repeats through the whole day, theoretically. Now, this is at 104 Fahrenheit air going in to cool components that cannot exceed 140 or 150 degrees Fahrenheit. So when you look at duty cycle in all reality, like in real life, unless that you live in Florida, Texas, New Mexico, Arizona, Louisiana, Mississippi, very rarely in real life do you encounter situations where the ambient air going into the machine exceeds 100 degrees Fahrenheit. Now, if you live in Minnesota, North Dakota, Maine, Wyoming, and it's winter and your shop is barely heated to like 50 or 55 degrees, and you pump 55 degree air in and it needs to cool components that cannot exceed 140, that's way more efficient than pumping 104 degree in. So now your numbers here go way up. And then with duty cycle, you have two things to consider. You have your initial till the machine shuts off, where you start with a cool machine and the machine has to, by welding, build temperature up in the machine, and then later on, as you hit your shutoff, this machine, as soon as it monitors the temperature in 3 different spots in the machine, once the temperature is deemed unsafe and too high, the machine shuts off for 4 minutes. It's a fixed 4 minutes, regardless of where you are, how cold or warm it is where you are, it shuts down for 4 minutes. Now, depending on if you're cooling air, if you're in Arizona and your cooling air is 100, 110, 115 degrees, those 4 minutes may not be enough. You may have to shut down for like 8 or 10 to let it cool enough. So now when you start welding again, you may not automatically see like another 2.5 minutes of service because you didn't let it cool long enough. In other scenarios you do. So duty cycle is a very individual thing for you, for what you do, for where you are, for what your ambient temperature is. And then very few guys really can weld out long sections of with a zip tie around the trigger. A typical welding or fabrication job is like cut a piece, fit a piece, tack a piece, weld a piece. Now sometimes you can't weld it all, you have to tack and fit it all, and then you can weld it all out at once. And if it's short runs where you have to move around a lot to mitigate distortion, that might be just fine. If it's a lot of bench welded parts where there's long runs, that's typically when you meet or exceed the duty cycle. Again, this machine, even if it goes into overtemp mode, besides of the inconvenience that it stops you for 4 minutes right there dead in your tracks, where the fans run at full speed, but you can't really weld anything, and you can't turn the machine on and off to reset it somehow. The machine will know when the 4 minutes are up. Besides that it's inconveniencing you, it's not really hurting you. The machine has very sophisticated protection electronics in there that assure a long service life of your machine.